Assalamu alaikum, ni ne Abubakar Abdulhamid. Previous video mun yi implicit differentiation. So yanzu za mu solving wasu problems kan differentiation irin special cases, for example, wanda za su taimaka ma mutum wajen solving. For example, let us say y is, let me say 1 plus x squared to the power of cos x. What is the derivative of this function? So the best way to solve this problem is to tabbata cos x din saboda ba tana da relationship da x, dole ka tabbata ta sauko ƙasa. Me za mu yi ta sauko ƙasa? Taking natural logarithm of both sides. So to take natural logarithm of both sides, muna da ln y, a can muna da ln 1 plus x squared cos x. In this case, logarithm log in nan da ce idan kana da log something to the power of b nan ga wani base b din za ta iya dawowa nan baya ya zama b log a. So in this case ma ln y is something as cos x ln 1 plus x squared. So yanzu za mu iya solving, za mu iya differentiating wannan implicitly. Derivative of ln y is 1 over y, amma saboda ba y bace ba x bace ba, kuma mu with respect to x muke to dole mu multiplying by dy dx. But in this case derivative din wannan two functions ne suke multiplying kansu, so dole mu amfani da product rule. F of x din mu ta zama cos x ln 1 plus x squared zama to shine g of x din mu. So product rule ta f of x, that is cos x, times derivative of g of x, that is 1 all over 1 plus x squared, but we have to multiply by the derivative of function in which is 2x. Then that's your plus g of x, that is ln 1 plus x squared. Then we have to multiply by the derivative of f of x, that is sin x, negative sin x. So this is positive, but in iteration we dash negative sin x. So this is it. Shine kawai yanzu next shine mu multiply by y dan mu bar dy dx ana, saboda dy dx kawai muke so. So if we multiply both sides by y that you cancel wannan dukan su kuma an yi multiply din su by y ta cancel, so write dy dx, and now dy dx is what? 2x cos x all over 1 plus x squared minus ln maybe 1 plus x squared to the power of what? Sin x. Dukansu multiplied by y. And y is 1 plus x squared to the power of cos x. So multiplied by 1 plus x squared to the power of cos x. Wannan shine. Now multiplying by y. Watch y din. And y din kuma already mun san cewa it is what? It is 1 plus x squared to the power of that. So by present. So this is the approaching problem with power. For example, if you have y equals to 7 to the power of x, derivative din shi dole ka dau ln of both sides, zai kasance ln x ln 7. So in this case, they can differentiate implicitly 1 over y dy dx. Now kuma zai kasance what? Ln 7 shine derivative din wannan, because derivative of x is 1 times ln 7 and so on. So you have to multiply by y. So dy dx in this case is equals to y ln 7, and y mun san is 7 to the power of x, so dy dx is what? 7 to the power of x ln 7. So this is yadda za a yi irin wannan form, yadda za a yi differentiating irin wannan function din. What about if you have what is the derivative of y equals to sin inverse of x? What is the derivative of this function? Ko cos inverse, ko tan inverse, ko anyone that ka iya yi. So to do this, sai mun dan ƙara mai da shi a wani form din, saboda mu ba mu san na sin inverse of x ba, mun san na cos inverse, mun san na sin ne, mun san na sin inverse of x. So abinda za mu yi anan shine mu cire inverse din by taking sine on both sides. So sine y is equals to what? Sine inverse of this, that is sine inverse of x. So sine is a theta sine inverse is a theta sine. So we have only x. So technically sine y is equals to sine x. One away again. So from here, let me differentiate implicitly. So derivative of sine y zai kasance cos y, amma saboda ba ta da x dole mu multiply by the x. Derivative of x is 1. Because of this, muna neman dy dx ne dama already, so we have to divide by what? By cos y. Divide both sides by cos y. Cos y. Y cancels this. So y is equals to dy dx is equals to 1 all over cos y. But we know y is sine inverse of that. So this is something as cos sine inverse of x. That is cos y, because y is cos sine inverse of this. So what if this sine inverse of x then? Sine inverse of something mun san cewa is duk abin da ke cikin function din is opposite over hypotenuse, because from SOHCAHTOA mun san cewa sine sine angle din theta probably is equals to opposite divided by hypotenuse. So if we have a right angle triangle, haka, one side din shine sine inverse of x din mu, that is theta. Alright? Shine sine inverse of x, theta kenan. So wannan ya nuna cewa x din nan opposite ne over hypotenuse. Because to find wannan theta din, zaka ce sine inverse of opposite over hypotenuse. So wannan angle in theta shine wannan sine inverse of x. So wannan x ne is something as opposite over hypotenuse. So wannan ya nuna cewa ɗaya yake da x over 1. So hypotenuse din mu, opposite din mu is x, that is opposite of angle din, opposite in the angle ɗin yake kallo. Then hypotenuse is 1 here. So that means menene no, side din, using Pythagoras theorem, which is square of the hypotenuse, wannan side din zai kasance abinda Pythagoras ya ce, let us call this p. So this p square plus x square into Pythagoras is equals to 1 square. Pythagoras theorem, square of the hypotenuse goes to the sum of the square of the other two sides. So p muke nema menene wannan? So p is something like square root of 1 minus x square. So nan wurin is square root of 1 minus x square. So what is cos sine inverse of x? What is cos of this angle? Cos sine inverse of x, that is cos 1 angle then, is equals to adjacent all over hypotenuse. Adjacent all over hypotenuse. And what is adjacent is root of this. Root of 1 minus x square all over hypotenuse. Hypotenuse is 1. So cos sine inverse of x is something as root of 1 minus x square over 1, which is 1 minus x square. Because of this, dy dx is equals to 1 all over root of 1 minus what? X square. Abin da wannan yake nufi, derivative din sine inverse of x, sine inverse of x with respect to x, it is something as 1 all over. So the end of x square, the end of sine inverse of x derivative into simply is 1 all over root of 1 minus x square. So using this method, zaka ga cos inverse of x, tan inverse of x, and others. So this is it. What about the case? Let us quickly do solve one more example. For example, you have a function y equals to log let me say x square sine x. No, let me just leave it like this. What is the derivative of this function? This log ne, akwai rule na logarithm ta ce idan na log ne, whatever base din ne na log a, wannan base, wannan muka ganshi log haka, so that means base 10 ne na. Amma yin akwai base, so normally mai amfani da base. So let us say akwai base din anan, so ɗaya yake da ln a over ln base din. So wannan y is the something as ln x square all over ln 10. Saboda nan 10 ne. Base 10 ne, sai ba a rubuta. So because of this, zamu iya gano derivative ɗin wannan. Derivative ɗin wannan kawai dy dx is something as derivative of ln 1 over x, ln x square, which is 1 over x square. So muna da 1 over ln 10 ne already number ne. So derivative of ln x square zai kasance 1 all over x square, but we have to multiply by the derivative of one function ɗin, which is 2x. So 2x cancel, x cancel 1x, da ke nan ƙasa, so muna da 2 over x.